Hello? Is everybody back? Or should we wait? Is everyone back in the class, or should we continue, or should we wait? Is anybody there? I'm not hearing you. Okay, sure, no problem. Take your time. Please let me know when everybody is back. Okay, yes, okay, so it means everybody is back. If the kurtosis is 3, what will be the variance? Yeah, compute it. You have the equation. The variance will be, should be, in that case, I think the variance should be very small, because whatever variance do we have for a normal distribution, kurtosis is 3, which means it's a normally distributed data. Of course, it's not that we won't have any variance. We will have some variance. So compute it. And I don't think I should say it should be 0. I'm not sure about it. But whatever it is, it should be for the one that we have for the normally distributed data set. Okay? It's a good question. I'll find the answer. I'll find the answer for it. Maybe it's 0, that I'm not sure. But the one thing is that the mean, mode, and median will all be same, because it will be with the kurtosis of 3, it will be a perfectly normally distributed curve. Okay. Now, before we go to our next slides, for which I really want you guys, I know that all of you are paying attention, but just more attention, because it's a little difficult concept to understand. However, it's a highly important concept that we understand. Standard error of the mean, most of the time we just neglect it, we just avoid it, but we should not. The reason being that if I am your supervisor for your dissertation or for your thesis, and if I'm your guide, I'm in your committee, I'll ask you this question, that do you think that sample size that you have collected for the analysis is enough? Did you do any checks onto it? And there comes this parameter of the standard error of the mean. So there are a couple of slides which are related with this concept, but before that, let's look at let's see how the computation, the calculation of kurtosis and skewness using Spss data set. So, is this screen visible? The Spss data set screen, the software screen is visible to everyone, or not? No. Okay. How about now? Okay. Thank you. Thank you. So I go here to analyze, and then I go to descriptive statistics, I go to frequencies, and then in the statistics, it gives me an option to compute the skewness and kurtosis of the data set. So I hit yes here, okay, and we see. What do we have here? See, the kurtosis is minus 0.189, and the skewness is minus 0.4. This is a negatively skewed data set, which means the data set is skewed more towards right, more towards left, and the kurtosis is minus 0.189. Again, it's showing me that this data set is not normally distributed. And let's look at the shape here. This is the shape here. So, of course, by looking at this distribution and the normal curve that is drawn around it, just the visualization of this data set or this histogram or the distribution tells me that the data is not normally distributed. However, computation of these parameters, skewness and kurtosis, it confirms my claim that the data of the heights of the students in the class is not normally distributed. Now, if I want to develop models, then I should think about transforming the variables or some other kind of treatment so that my data is more close to the normal distribution. Okay? So you go to analyze, and let's see if it has it in the descriptive statistics. And options. Yes, it allows me to compute the kurtosis and skewness. See, these are the different, though we discussed the mean, mode, and median. However, these are the other different parameters that gives me that tells me about gives me an idea about my data set, the minimum value, the maximum value, the range of the data set. However, these are the very I should say these are the very not even basic. These parameters tells me, yeah, okay, this is the minimum height, that is the maximum height, but again, it does not give me a proper idea about the distribution or about the overall feel of the data set. So these are some of the basic parameters as well that you can compute using the SPSS software or Excel as well. However, since we are using the SPSS, so we are doing a hands-on using it. So now let's go back to our slides here. Now, when you will read the first bullet, it will take some time to digest it, to understand it. The standard error of the mean is the standard deviation of the sampling distribution of the sample mean. So there is too much samples and too much deviation and all that. But when we'll discuss this, it will become easier for you to understand. Now, for example, if I send you all, if you are like, let's say 8 students in the class, and if I send you all to go out and collect the speeds of the vehicles, each of you collect the speeds of 50 vehicles. 8 students will give me, then when you come back, you will compute the mean of the sample that you have collected, which means I will have 8 different means, right? Because 8 students collected the data out in the field, and each of you computed a mean of the sample that you collected. All of these samples were drawn from the population of the vehicles. How do I know whether the means that all of you have computed are representative of the population mean, or what is the distribution of it? Again, there is a randomness into it. There is a variability into it, right? The mean will vary from student to student, from sample to sample. There will be a randomness into it. When I plot the means, the distribution of the means that you have computed, then the standard deviation of that distribution from the population mean is the standard error. Again, let's discuss it in the few upcoming slides, and it will become easier to understand.